Let's give a try. SharePoint. I'm getting this option for slide share. It's not. Oh, wait a moment. I'm looking for this. I'm portion of screen. That is new share. Second. You could just Are you able to view my slides? Hello? Hello? Let me do it. Sorry. Is it clear now? Okay, fine. But it is normal. Okay. Let me. Wait. Okay. Is it okay now? Still, it's 100% here. Now, is there any change? It's large. What about this one? Why? Why so? Wait a moment. Watch shares. मेरा फोटो लिखा है। यहाँ पे तो okay. Now wait a moment. Oh no, I'm just making some adjustment. Wait a moment. Is it okay now? Okay then. Okay. So sorry for the inconvenience. Now, why we need statistics? Because stress a different field, yours a different field. So why we need this statistics? What we do now, what researchers do is when they conduct the research, what do they generate when they conduct the research? You can be interactive, right? You can open your mics and you can be interactive so that. So that's later on. So the first part is you generate the data from your experiments, because you are now in the third semester. Maybe you may have to start your research, or some of you may go into the PhD program. Then there you have more research to do, because in the masters there is the basic research, but in PhDs you do the advanced research. So everywhere what you do is you generate the data through your experiment, because in research you conduct the experiments and you generate the data. Now, the numbers which you collect, the data which you collect from your research, those numbers, they contain the information. And what we statisticians do is we apply statistical tools on your data to extract that information from your data. So we will first discuss the basic concepts about the statistics. So this was why we, use why you guys need statistics in your research. So what to do with that data? For that, you need to have some, knowledge about statistics. So in statistics, what we do is the statisticians gives you the plan to conduct your experiment. It's just the same way if we have to construct a house. Whom do we approach when we have to construct the house? Whom do we consult? Whom do we consult for, constructing the house? We consult an architect, right? So he gives us the design. He gives us the plan that how we should proceed, how we should make our house. So same way the statisticians, what we do is we give the plan to the researchers that how they should conduct their experiment, how they should, conduct their experiments in a scientific way. So we give you the plan because there are different plans for different situations as per the objectives. So as per the plan, you generate the data. Once you generate the data, so that's the first step. That means you collect the data. That's the first step. Once you collect the data, you need to summarize the data. We summarize the data in different ways. One of the ways we summarize them in the form of the tables or diagrams or charts or certain numbers we use to summarize the data. Once as I said, that once you have data with you, we need to extract the information from that. So by extracting the information, we mean that we need to interpret the data. What data contains, whatever the information data contains, we need to interpret that. So to draw the valid inferences from the data and forecast the future outcomes in face of uncertainty, we have to subject it to certain minimal assumptions. Now, this is a definition for the statistics. It's a branch of scientific methodology which deals with data collection. Then after data collection, we go for compilation of the data. Then we go for the analysis and interpretation of the data for drawing sound and valid conclusions. In statistics, we use the certain terms. We use the term as the population, and we use the terms as a sample. Since whenever you conduct the research, it's not possible to study the whole population. What we do is we study a part of the population, a small portion of the population. On the basis of that small portion, which we call as a sample, so we study the sample and we draw our conclusion. We give our interpretation for the population. Now, the population is your aggregate of individual or units. For example, a population of human beings or animals, or a set of definite measurements like body weight of animals or a set of plant heights. So in simple way, we can say, for example, if we have the number of students in Kashmir University, so the total number of students of Kashmir University is my population. If I have to study the average height of the students studying in Kashmir University, so from that population, I will draw a sample of students. Maybe if the population size, by population size, I mean number of students of Kashmir University, maybe there are 5,000 students, so that's my population. So out of 5,000, I will study only, let's suppose, 100 students. So 100 becomes my sample. Studying that sample, we will record the height of all the 100 students, and that sample will represent your whole Kashmir University. So that's the population. So we use the terminologies, parameters, and statistics. Now, if we characterize the population, those characters we call as parameters. If we characterize the samples, those characters, quantities, we call them as statistics. As I said, the population of the university, we can have the mean. If I study the whole population, that's all the 5,000 students of Kashmir University. If I study the mean for that population for 5,000 students, that mean we call as parameters, as parameter. Or if we study the standard deviation or the variance for the whole population, those we call as parameters because they pertain to the population. But if I study only the sample, that's only the 100 students, and I calculate the mean for the 100 students, which is my sample, we call that as statistics. Similarly, we can have standard deviation for the sample. So standard deviation and mean of the sample is my statistics. But standard deviation and mean of the population, we call them as parameters. Is it clear? Okay. Then we have variables. By variables, we mean, the things which keep on changing. By change, we mean if we have student 1 that has a height of 160 centimeters, then we have second student. So the second student will have a different value for the height. So then the third student will have some other value for the height. So these we call as the variables which keep on changing. Now the data which you guys record during your research, there are different types of data which you record. Either you record the quantitative data or you record the qualitative data. Then quantitative data is in terms of two types. One is continuous and one is discrete. Now, what do we mean by continuous data? Now, see, when you study the height of the student, the height can be, you can have decimals there also. That means you can have a height of 160.7 centimeters, 166.3 centimeters, 160.0 centimeters. Similarly, you can have weight. If you record the weight in kgs or in grams, the weight can be 47.9 kgs, 47.3 kgs, 33.8 kgs. So that means decimals are also there. Such type of data we call as continuous data. By discrete data, we mean if we have number of students, we can't have number of students as 30.3 or 30.7. The number of students, so you can have whole numbers there. The students can be, you can have 5 students, 33 students, the number of students. Such type of data we call as discrete data. Then we have qualitative data. In qualitative data, now we may have, we may have females, we may have males, we may have number of students who have passed and who have failed. Such type of data we call as qualitative data. So it's because in statistics, it's very important the type of data you are recording in your research and what that data means, whether it's continuous, whether it's discrete, whether it is quantitative, whether it is qualitative. So as I said that you have to, the first step is the data collection. In data collection, it's a different field altogether. Then there are different sampling schemes which we use. We have simple random sampling, we have stratified random sampling, systematic sampling, cluster sampling, multi-stage sampling. So we won't go into those details, the methodology which we'll be using for data collection. So we will assume that we have collected the data. Now, the first step, as I said, is after collection of the data, it is summarization of the data. The summarization can be done, as we discussed in the previous slide, it can be done either through charts, diagrams, or tables. And then there is one more term in the form of the numbers. So here we will be discussing about the numbers part. For numbers, we use the measures of the central tendency. Under measures of central tendency, we have different types that we will be discussing. Now, let's first discuss what we mean by the measures of central tendency. It indicates the center of the distribution the data represents. That means it will give you a single value, and around the single value, the whole of the data set will, exist. So any measure of central tendency, if it were to indicate the general tendency of all observations to cluster around it. So the single value which we will calculate, all the observations will cluster around it. So they should perform one important function. That is, it should be representative one for all the observations. Whatever the observation you will give, because you are summarizing your data, you have a large data set, and you have to, let me give you a simple example. We usually say, hey, my car gives an average, average mileage of, let's suppose, 12 kilometers, right? So what do we mean by this average of 12 kilometers? Now, if I go from, from Hazratbal to Lal Chowk, your car may give you an average of, let's suppose, 7 kilometers. Or a mileage of 7 kilometers. But when you go from Lal Chowk or Hazratbal to Anantnag or Hazratbal to Sopore, that means you cover a longer distance. You will have some different, mileage of your car. Maybe it may give you 17 kilometers per liter. But whatever we say, whenever we have to say about our car, what we say is it gives an average of 12 kilometers. So all the data points, they are represented by a single value. So that single value should be a good representative for all the observations. So what are the properties for that good measure of central tendency? It should be based on all observations. It should be rigidly defined, easily comprehensible, lend itself for algebraic treatment. It should be least affected by extreme values. So these should be the properties of any, the good measure of central tendency. So what are the different types of, the measures of central tendency? We have mean, median. Maybe you may have, heard these names before. What we mean by mean, median, mode. Geometric mean, harmonic mean, quartiles. These are all various types of, the measures of central tendency. And every measure has its own use. Every measure has its advantage and its disadvantage. So we'll be discussing few of them. So mean is a single value that could describe the characteristics of the entire data. So the representative function of mean is still good when the observations are not widely different from one another. It's symbolized as mu. So this is, the formula which we use for calculating the mean. That's mu is equal to, so this Greek symbol is called as, sigma or summation of xi upon n. Now, here you have the two formulas. One is mu, one is x bar, right? The mu, which is our Greek symbol, these are used whenever mu is written in the textbook or in the formula, it means that it's for population. Because for population, we use the different symbols, and usually for population, we use the Greek symbols. And for sample, we use the Roman letters like X bar, Y bar, Z bar, whatever it is. So the mu is your population mean. It is denoted by sum. It is the summation sign. Sum, you have to sum all the observations and divide it by the number of observations. Now here we have a small example how to calculate mean. Suppose the weight of 5 babies is 3 kgs, 6 kgs, 6 kgs, 9 kgs, and 11. So we need to calculate the mean. As per the formula demands that we need to sum up all the values and we need to divide it by number of values. So we will, first step one will, we will add up all these values. So it is 3 plus 6 plus 6 plus 9 plus 11. That's 35. And we will divide it the number of babies. So number of babies we are having here 7. That means the number of data points 5. So it will be divided by 5. 35 divided by 5. So it is sum of x divided by n, which is 35 by 5. That's equal to 7 kg. So it becomes your, the mean. So this mean will represent the data set. That means 3, 6, 6, 9, and 11. These were the observations for the 5 babies, but we will say that the average weight of, or the mean weight of 5 babies is 7 kgs. So this single value represents all the data set. That's what we mean by, the measures of center tendency. Is it okay? Okay, fine. See, this is the graphical representation for this mean. It's the center. It's almost a central value, not exactly the central, but you get a central value. Now, when you calculate the mean, because some of the observations will be to the left side of the mean, some of the observations will be to the right side of the mean. When more of the observations are to the left side of the mean, we say that the data is positively skewed. If more of the data is, on the left side of this, we say it's negatively skewed. So every observation in the distribution affects the value of the mean. As a result, the mean is always pulled in the direction of extreme observations. जिस साइड में आपके पास ज्यादा ये होंगे extreme observations, the mean will be pulled in that direction. By this we mean that the mean will be towards the higher values of the data set. So when you have a data set like this, so we can have example of why it is better to use median is family income. So as a result, mean is always pulled in this. This is this. Okay, so we'll have some next one. Then we have mode. This is one more, type of central tendency. First was mean, then it is mode. Now, when to use mode? Observations which occurs more often than others. At that moment, we have to use mode instead of mean. So this is the only measure that can be used with nominal level of variables. The limitations for mode is it may or may not exist. See, in mode, what we do is, let me see if I have. Okay, so in the mode we say that it may or may not exist. It's not necessarily unique. By necessarily unique, we mean that you can't have only one mode, right? So this example will clear it. Let's suppose we are saying that we have 10, 10, 9, 8, 5, and 10. Is the slide, are the slides clearly visible? Okay. Now see, if we have the observations 10, 10, 9, 8, 5, 12, and 10, there are two ways, to calculate the average. Either you can use mean for this, or you can use mode for this. So if you have to calculate the mean, you will just sum up all these observations and divide it by the number of observations, right? Is it okay now? Okay, fine. Okay. Now see, these 10, 10, 9, 8, 5, 4, 12, and 10. This is your data set. You can calculate mean for this by summing up, adding up all these observations and dividing by number of observations. But if you do that, you can have only one value for mean. But if you calculate mode instead of mean, you calculate mode for this data set. So as far as definition of mode is concerned, as you say, it is observation which occurs more often than others. So here, which is the observation which occurs more often than others in the first example? It is 10, 10, 9, 8, 5, 4, 12, 10. So which occurs the maximum number of times? It's 10. So 10 will be mode here in this case. Now in second case, what are the observations which occur maximum number of times? So for example, second, you are having two modes. That's why we say that it's not necessarily unique, which is the limitation for it, right? So unique means you can't have only one single value for mode. Sometimes you can have two modes. So here the mode is 9 as well as 10. Then in example third, 4, 6, 7, 15, 12, 13, and 10. Which observation occurs maximum number of times? They all occur, same number of times, right? They all occur once. So now if you come back to the limitation one is it may or may not exist. So for example, third mode does not exist, right? Okay. So then we have one more, measure of central tendency, which we call as median. So in median, what we do is we arrange the data in ascending or descending order. In mean or mode, we don't do any such thing. We don't arrange the data, right? But if for calculating the median, we need to arrange the data in either ascending or descending order. So it's a value of the variable in the middle of the distribution. It's same as the 50th percentile. So when you arrange the data, you can have two cases. When your number of observations is odd, that means you may have, for example, you may have 5 observations. So n is your odd here. So when you arrange them in ascending order, you can have the central value as the middle value of this. So that means 6 is the central value. You can have median is equal to 6 for this. When n is even, that's median is the observation between the middle two cases. Now here, if n is 6, so you can't have one central value here. You can have the two values. You can have 5 and 9. What you do is, in that case, you divide 5 plus 9 divided by 2, you will get 7. So this is how we calculate median for when n is odd and when n is even. Now see, if we have an example, we will calculate all these three measures of central tendency. We will calculate mode, we will calculate median and mean of the following numbers. For data set is same, so we will calculate all the three measures. Here the mode is, as we say, that mode means the most commonly occurring observations. The most commonly occurring observation here is 2, so mode will be my 2 here. Now median, by median we mean the middle value. Now for calculating the median, we will first arrange the data in ascending order. That's 1, 2, 2, 4, 5, 6, 8, 10, 11, and calculate the median. So here we get the median as 4.5. Now if we have to calculate the mean, we will sum up all these observations and divide it by 10, because we have 10, the number of observations we have 10. So the mean for this data set will be 5.1. So mode is 2, median is 4.5, and mean is 5.1. Let me go to this. Now, if we compare all these three, mean, median, and mode, the mean gives you a distracted picture when data contains some extreme observations. That's the only problem with the mean. When there are extreme observations in the data, it gives you a distracted picture. it's less affected by fluctuations of random sampling, so leave it. Readily lends itself to, okay, so it readily lends itself to algebraic treatment than median. We can use, because the mean is your central value, but what else we can do with this value, that's what we mean by algebraic treatment. That means we can use this observation, this average, for some other purpose of analysis. It's considered as the best of the all. There is only one disadvantage with the mean, that's it's affected by the extreme observation. Otherwise, it's the best of all. The reason being, this value is based on all the observations. It takes all the data into consideration when we study the mean. For median, it is suitable measure when data contains some extreme observation. So when there is extreme observation, mean has a problem. But in that case, what we can do is we can use median instead of mean, because it's saying that it's suitable measure when data contains some extreme observation. Then we have mode. It is suitable measure in studies related to preference of an item. So this is usually used, for example, if you have any shoe company and the shoe company wants to manufacture a particular size of the shoe, right? So what is what should be the maximum number of shoes of what size they should produce? There we use the mode. It's very unstable. That's the disadvantage with this. It's very less known about its mathematical properties. Now, whatever the measure of central tendency you are using, it won't give you the correct picture of the data. So what we do is, in addition to study the mean, median, or mode, what else we can do is we will try to study the variation in the data. What sort of variation, what type of variation the data has. For that purpose, we use another measure which we call as measure of dispersion. The word dispersion itself is self-explanatory. We try to understand how much the data is dispersed. That's what we mean by dispersion, how much variation is there. So there are different types of variations, the dispersion measures which we use. We use variance, we use standard deviation, we use mean deviation, we use interquartile range or range. Have you guys heard, studied these basic things like standard deviation or variance before this in your UG program or this? Hello. Okay, variance and standard deviation, right? Okay, so the most commonly used is variance and standard deviation. All right. So what it means is, on an average, how far each and every observation deviates from the mean. As I said, you will calculate a mean. Now what we try to find is that on an average, how far each and every observation that will deviate from this mean. That's what we try to study in measure of dispersion. So we study that in terms of variance or standard deviation. Now, if you have first one, example first. Now, if we calculate the range for this, see, mean will be same, because as we said, that mean will not give you the correct picture. Now, for all the three examples, you will see that the mean is same. Is it so? 60, 60, and 60 for these three examples. But if you calculate the range for this, the first one, there is 0 range. The second is there is 55, and the third is 80. So that's where the measure of dispersion plays its role. You are having the same mean, so we want to look further. Then we try to study the variability, because it won't give we can't say on the basis of the mean that these three examples, that these three data sets are same, because we have to take into consideration the variability part. So these are the different measures of dispersion: the range, mean deviation, standard deviation, variance, and interquartile range. Since we have less time for this, maybe we may go direct, because range is nothing but it's the simplest measure one. Highest value minus lowest value gives you the range. We will go to directly to we'll go to standard deviation. Now, standard deviation is the positive square root of the average sum of squares of deviations of all observations from their mean. This is how we calculate the standard deviation. Now, see, you have a data set 52652. What you guys do is you will calculate the mean for this data set. When you calculate the mean in the next column, from every observation you will subtract that mean. That's xi minus x bar. So xi is your observation minus you will subtract the mean. So you will get, this second column. Then you are having third column where it is written 14414. This third column is you square the second column. That's xi minus x bar. You square it and you will get the third column 1 4 4 1 and 4. You square 1, it's 1. You square minus 2, it becomes 4. So then this is the formula for standard deviation. Now standard deviation becomes your 14.5, it becomes 2.8, which your variance, and SU, when you take square root of 2.8, it becomes your 1.67. So S square is used to denote the variance. S is used to denote the standard deviation. So we'll be back in 10 to 15 minutes. Now, if you have any questions, you can ask me in the next presentation, because I think it's about to end. Welcome again. Is right now the screen visible? Okay. So before this, we discussed about some basic which we use in statistics, like mean, standard deviation. So I would request to you all, upcoming researchers, you students, that at least you should study about mean, standard deviation, and variance, as well as median. So mean and median, as well as standard deviation and variance. So at your own level, you should study about these 4 things, because these are the most commonly used statistical terms you use in your research. So it will be of good help to you, because mean is just not it's just not a formula or a you need to study about it in detail, its advantages, its disadvantages, what we mean by that, as well as the types of data. What types of data, what we mean by types of data, like continuous variable, discrete variable. So these things you can, study at your own level. Okay, so shall we start the second one? Okay. See, whenever we conduct an experiment, there are certain experiments where you get the exact results. Whenever you repeat the same thing, you get the exact results. There are certain experiments where you do the same things, you repeat the same things under the identical conditions, but you get the different results. If you remember, in physics or in chemistry, we do certain experiments like we study those Boyle's law, Ohm's law. So whenever you change the things, every time you get the same results, right? But in biological or agricultural experiments, if you repeat the same things under the identical conditions, every time you will get the different results. So you are having variation, same experiment, same thing, same conditions, but you get the different results. So we are having two. One is exact one is exact situations. One is, or exact outcomes every time you get. And the second one is you get different outcomes under identical conditions. So that happens in biological or agricultural experiments. So when one can predict the outcome of an experiment in exact sciences, such a prediction is not possible in biological or agricultural experiments. Even if the experiments are repeated under exactly identical situations, the observed results that will differ from one another. So in experiments of these sciences, we essentially get a sequence of results by repeating the experiments, and such results, they constitute a set of statistical data. So once we have, such data where you get, because as I said that in exact sciences like physics and chemistry, whatever you do, you every time you get the same results. That means if you change a particular voltage, you get the same current. Every time you get the same. But in biology or agriculture, it's not like that. So we try to analyze these problems in which the data depart from the laws of exact causality. So that's what you do in your, research. Then there you have two types of reasoning. Whenever you conduct a research, you have two types of reasoning. One we call as deductive reasoning. Second we call as inductive reasoning. In deductive reasoning, what we do is, whatever the reasons we give from general to the particular. But in inductive reasoning, we give it from the particular to the general. So it's vice versa. Now, what we mean by this will be clear in this slide. Now see, deductive reasoning and inductive reasoning. Given the general formula for the area of a circle, which is A is equal to pi r square, what's the area of a circle whose radius is 12 inches? So this example is a case where we have to go for deductive reasoning. That's from general to particular, because general is your A is equal to pi r square. Then you have a particular case, we need to find the area of a circle whose radius is 12 inches. So we are moving from general to particular case. So this we call as deductive reasoning. Now, inductive reasoning, you are given the area and radii of several circles. When we are given area and radii of several circles, we try to establish the relationship between these two, area and radii. That means we need to find the formula for it. So this is a case from where we move from particular to a general case. So what general formula can we give expressing the relation between area and radii of the circle? Now we can just, compare these two same things, but under different categories. One is deductive, one is inductive. Then you have second one, given the Boyle's and Charles law, how do we expect a certain volume of a gas to change when subject to certain change in pressure and temperature? So here again, we are moving from general to a particular case. Particular is you have certain change in pressure and temperature. So from general to particular. So given a series of observations on the volume of a gas under different conditions of pressure and temperature, what general laws will account for these observations? So here you are having volume of different conditions under different conditions of pressure and temperature. So when we have that, we try to establish the relationship between these two. Only then we can reach to a particular formula, which will be used in future for for general to particular. So whatever the formulas are established, like A is equal to pi r square or Boyle's law and Charles law, they were in fact started from, they conduct certain research. So you are having different observations for different inputs. On the basis of those, they try to establish the relationship between these variables, and they reach to a conclusion where they constructed the formula which we call as Boyle's law or Charles law. Now the experiment which you have, what you do is, what we do in our experiments as a researchers, what you do in your experiments. Can anybody share his views on it? When you conduct the experiment, what you guys do? Hello, are you there? So what do you do in your experiments? Where are the other students? I think there is only one who is, interacting. अरे यार मास्टर्स में भी शायद रहेंगे तो शायद तो रहते हैं 10th से पहले. Everybody is shy. Mostly the students are shy after 10th. Then after 10th, you have to be very bold and active.
So we actually just first analyze a problem and then collect data for it.
No. I mean, say that what do you do in experiment? If you are in a lab, what do you do? If you have to conduct an experiment, what do you do in labs? Whatever, okay. I know that we do the existing ones, we try to find what they have done, how they have done, we try same things. So what we do is, see, that's why the experiment, the factors being studied, they are made to vary in some systematic fashion by the application of the treatment. So you are giving something, you are changing certain things, and then you try to, record or observe what are the changes. When you change a particular thing, what's the change in the response, right? You try different things and you try to, find what is the change in the outcome. So that's what you do in experiments. So when you do that, on the other hand, you try to minimize certain things, that there should not be much variation in the outcome. So you are studying certain factors, and on the other hand, you are minimizing other factors as much as practical, right? So we then have an experiment. So the researcher's problem. Nearly all problems encountered by a researcher are those requiring inductive reasoning. That means you have to move from a particular case to a general case. You will study a particular case and then you will generalize your results. That's what we mean by inductive reasoning. See, what's the typical problem that confronts the researcher? That's now the problem is, will the use of new or different technique or method or drug affect the outcome of some particular segment? And if so, to what extent? because this is the what the researcher tries to study in his or her experiment. They try a new technique, they try a new method, they try a new drug, and check the outcome of some particular segment, whatever the outcome will be, and if so, to what extent that changes are. But these, whatever the results you will give, you won't be answering them with 100% certainty. You have to consider the risk and cost of making an incorrect decision. Maybe sometimes whatever the results you give, maybe sometimes, most of the times your decision will be correct, but sometimes there is a chance, because as we said that your answers will not be of 100% certainty. You will always say, I am 97% confident of my results, that whatever I am saying is correct. So that means 3% chances that you may give an incorrect decision. So we have to consider the risk and cost of making that incorrect decision. So to answer such a problem, an experiment is generally required. So the elements of chance, what are that? So whatever the design of the experiment, its purpose is to provide a means of making observations that can be used for making plausible generalization about the practice under study. As I said, you have to move from the particular to the generalization case. So you have to make it plausible. Now, in the problem of finding the area of a circle, there is no uncertainty, right? So there is no element of chance if we have to find the area of the circle. Whatever you have the radii, whatever you have the whatever is required for that, the area will be always exact. So there is no uncertainty in that case. But coin tossing problem is some quite different. Chance variations resulting from multitude of causes always makes the results vary, no matter how much effort was put into controlling all the factors. So this chance variation we need to minimize. Now, what do we mean by this chance variation? Now, see, suppose I am having drug A, which I am giving to a particular patient, right? Then the same drug A is given to some second patient. Then the same drug A is given to some third patient. Now, let's suppose I am having this drug A as weight gain. For gaining the weight, if I am giving a particular drug to one student, for example, the student gains a weight of 1.5 kgs in a month. Will the second student with the same same drug, same dosage, gain the 1.5 kgs weight? Hello?
Not possible.
It's not, because, so see, drug is same, weight gain drug is same for both the students, but the response is different. One is giving me a weight gain of 1.5 kgs, maybe second maybe give me a weight gain of 1.7 kgs, right? So that's what we call, we try to minimize that. So the variation, by giving the same treatment, by giving the same drugs, we are getting the different this. So that's why we call, because whatever the variation is there, that variation is due to chance, right? The difference. So what we need to do is the need for statistical evaluation. What we need to do is we have certain principles which we use whenever you conduct an experiment. You need to use 3 principles in your experiment. One is called as replication, second is randomization, third we call as local control. So now if I am having 2 drugs, let's suppose drug A and drug B, both are used for weight gains. If drug A gives weight gain of 1.5 kgs, drug B gives weight gain of 1.9 kgs. Can I say that drug B is better than drug A? Huh? If I give drug A to one student and he gives me a weight gain of 1.5 kgs. If there is second drug B, you also use for weight gain and given to one student, another student I mean. So that student gives me a weight gain of 1.9 kgs. Can I say drug B is better than drug A? We neither. So, like for example, if we have a new player in our cricket team, if he scores 100 in the first game, right? And for example, two players are new in the cricket team. One player scores, let's suppose 100, and second player scores 20. Can we say on the basis of the first game that player one is better than the second player? No, we need to try them again and again, right? We need to repeat them. So we need to give them more chances. So that's what we mean by replication. So we need the treatment is repeated 2 or more times. So that means if you repeat it more number of times, you will be more confident of your, decision. Which one is better? Whether drug A is better or drug B is better. So when we tried them on more number of experimental units, our precision, our accuracy will be high. So that's what we mean by replication. More the number of replicates, better it is. If you have to be more confident of your results. Then it is randomization. This is the one more principle which we use whenever we have to apply our treatments. Now, what we mean by this randomization? See, now if I have to test 2 drugs for weight gain, drug A and drug B. If drug A is given to, the healthy students, and drug B is given to somewhat weaker students, and then we can say at the end of the day, drug A is better than drug B. Is that correct way of doing things? No. So what we need to do is, because there will be a biasness. If drug A is given to, healthy students, drug B is given to somewhat weaker students, and at the end of study, we will say drug A is better than drug B. So the results will be biased. So what we have to do is then we have to make use of randomization. We need randomization. So in randomization, what we do is drug A will be given both to the healthier as well as to the weaker students. Similarly, drug B will be given to healthier as well as the weaker students. So there the randomization removes the biasness. So this principle is required whenever you conduct your experiment. Then we have one more principle, we call it as local control. So this we will be not discussing right now because it's a little bit tricky. Now, in the research, what you do is, as you guys said, that it's a systematic inquiry into a subject to discover new facts or principles. So sometimes if you are going for new discoveries, new inventions, you will try some new things. So that's what we do in research. Or whatever the one researcher has done, you try to, check whatever he has done is correct or not. So that's also a type of research. So what are the various steps when you conduct the research? The first step is you formulate an hypothesis. So now the question is, what do we mean by an hypothesis? Hypothesis is a statistical term. It's a statement, in fact, you guys make. Now, as I said, if you are having 2 drugs, drug A and drug B, you will start with the hypothesis that drug A and drug B are same. That's a statement which you guys are making, that they are same. Now, whether they are same or different, for that, in fact, you are trying to check that your hypothesis. Right? So once you conduct your experiment, at the end of the experiment, you will say whether the 2 drugs are same or different. That's why that you have to prove your statement. You have to prove your hypothesis. So that's the first step which you will do when you will start your research. Once you start to prepare your hypothesis, you make a statement, you need to plan, because you have to prove your statement. You need to plan an experiment to objectively test the hypothesis. So how to plan the experiment, that's, that will be, because there are different designs which we use to plan the experiment. Once that experiment is designed, as I said, when you conduct the experiment, what you guys do is you collect the data. You generate the data from your experiments. So you have to have careful observations and collection of data from the experiment. So once you are having data with you, you need to interpret the results. So consideration of results in the context of other known facts concerning the problem leads to confirmation, rejection, or alteration of the results. So what should be the characteristic of an experiment? How, when we conduct an experiment, what should be the characteristics? It should be simplicity. By simplicity, we mean treatment selection and experimental arrangement that should be consistent with the objectives. Because when you frame your objectives, because in research you have to frame your objectives. When you frame your objectives, as per the objectives, you need to select what types of treatments you are going to test. What should be the arrangement of your experimental units? So it all comes under your plan of experiments. That includes your treatment selection, arrangement of the experimental units. Second is, it should have a certain degree of precision. By degree of precision, we mean probability should be high to measure differences, which implies an appropriate design and sufficient replication. That's what we were just now discussing, what we mean by replication. So if you have sufficient replication, your degree of precision of your results will be high. Absence of systematic error. Ensure that the experimental units receiving one treatment in no systematic way differ from those receiving another treatment. So unbiased estimate of treatment effect is obtained. Absence of systematic error is obtained by the principle of randomization. If you follow the principle of randomization, you will remove the systematic error. Then fourth characteristic of a good experiment is it should have a range of validity of conclusions. By validity means that whatever, the results you are giving, whatever the conclusions you are giving, it should have a wide range. It should fit in under many different conditions. It's not that it should be for a particular case, for a particular conditions, it should suit. It should suit to a wide range of conditions. Okay. Degree of uncertainty. So experiments should be such that we should be able to, obtain what are the results of uncertainty. How uncertain we are, we should be able to estimate that part. So the previous slide was the characteristics of the experiment. This is the steps in experimentation. The first step, the selection of the procedure for research depends to a large extent on the subject matter in which the research is being conducted and on the objectives of the research. So important steps is the first one is definition of the problem. State the problem clearly and concisely. Once the problem is understood, you need to formulate the questions. See, as I said that in your research, the first part is that you start with your objectives. So by objectives, we mean that you formulate your question. You clearly state your objectives. It should not be, the objectives should not be vague. Once your objectives are clear, based on the objectives, you need to formulate your questions. By formulate your questions, you need to know what type of, what are the variables you would try to study, what are the observations you are going to study. So that will give you, once your objectives are clearly and concisely formulated. So that's the first step in starting the experiment. You need to define your problem clearly. Statement of the objectives. In the form of the questions, hypothesis to be tested, effects to be estimated. So you don't be vague or too ambitious. Sometimes what researchers do is they try to frame such objectives that, they want to achieve everything in that experiment. So we need not to be more ambitious. You need to be, careful. You need to keep your cost into consideration. You need to keep your time into consideration. You need to keep your facilities at your lab into consideration whenever you have to, prepare your objectives. So it should be clear, not vague, not too ambitious. Selection of the treatments. Success rests in careful selection. So whatever you are trying to compare, whatever drugs you are trying to test, you need to be careful in that, because selection of treatments will be based on your types of on your objectives. So you had definition of problem, first step, then statement of the objective, second step, selection of the treatments. See, once you have treatments with you, you need to apply those treatments. So where you will apply those treatments, that we call as experimental material, where you will test your treatments, where you will test your drugs. So selection of experimental objectives and the population be considered. Whenever you have to select your experiment, whether your experiment is on animals, whether it's on plants, whether it's on humans, so that will be your experimental material. Now, if you take, for example, humans, now in humans, whether it's on females, whether it's on males, whether it's on infants, whether it's on young children, whether it's on adults, whether it's on older people. So that will comprise your experimental material. So once you have with you objectives, you have with you treatments, whether you have, when you have your experiment material, then how to conduct that? It becomes then you are in a stage of experimental design. You have to design your experiment. Once you have with you the treatments to be tested, the experimental material on which it's to be tested, then comes the role of the, the statistician here, that what type of design you will use to compare your drugs, to compare your treatments. So you need to keep your consideration of objective. Choose simple design that provides precision you require. Selection of the unit for observation and the number of replications. This is we were discussing just now, that what should be the number of replications, and it all depends upon, the precision you require. Consideration of data to be collected in line with the objectives of the experiment. So this we mean that what type of data we need to collect, whether we need to go for discrete data, continuous data, qualitative data, quantitative data, that you need to consider. Step 9 is outlining the statistical analysis and summarization of the results, because once you conduct your experiment, you will come up with the data. The data will be generated from the experiment. Now it's to be, as I said, once you have data with you, it's to be analyzed, because the information which the data contains will be extracted only once it is analyzed. So for analysis, we have ANOVA. ANOVA is a short form for analysis of variance. We have summary tables or graphs. Once you have results with you, you need to compare the expected results with the objectives and review your plans. Then step 10 is conducting the experiment procedures free from bias, experimental design to collect data, avoid fatigue in collecting data, recheck the observations. Whenever you collect the data, you need to recheck them, because sometimes you may commit certain errors while entering the data, while recording the observations. You need to check those. Analyzing the data and interpreting the results. So we will analyze the data based on the objectives you have, based on the hypothesis you have. So in light of the experimental conditions, hypothesis tested, and the relation of the results of facts previously established. As you were, saying that research you do is what already has been done. You just try to, recheck that, revalidate those things. So the results which you have achieved and the results which others have achieved, you try to compare them. So preparation of complete, readable, and correct report of the research. So there is no such thing as negative result. See, I don't know whether you have heard the terms. We say that, hey, whether my results are significant or not. Usually the research say, if my results are non-significant, it's not you have failed in your research. So that's what we call as negative results, non-significant results. So that's what we say, that there is no such thing as negative result. Whatever the results are results. Whether it's in your favor or not, you just have to defend your results. Why so? So learn and practice the 3 R's of experimentation. That is replicate. As I said, the precision of your experiments depends upon the number of replicates. So we need to replicate it. Then randomize. So I said the randomization is done to avoid the bias, to remove the biasness. It's not that a particular good treatment you will give to a favorable, students. And third is request help. Ask for help when in doubt. Be on guard against common pitfalls. So remember these 3 R's whenever you conduct your research: replicate, randomize, and request help. Replicate will give you the good validity of the results, precision of the results will be high. Randomize will improve the validity of your results. It will remove the biasness. And help. Whenever you are in doubt, ask for help. So this was all for you regarding your research and experiments. If you have any questions, we have 5 minutes left for discussion. Feel free to ask any question. Hello. Feel free to ask any questions if you have. Right. See, you need not to become the statisticians, because see, this research is always a teamwork. The idea behind these lectures, these statistics lectures to you guys, is just you guys become acquainted with these terms which you will read in the research papers or this, because as I said, it's a teamwork. By teamwork we mean that a statistician has a role to play, then you have to consult a statistician during your research. In fact, before starting your experiment, you have to consult the statistician who will give you a plan of your this. First, you have to see, if you remember these steps of the research, you have to select the treatments, that's your part. Frame your objectives, that's your part. Selection of experimental material, that's your part. Then becomes, if you have all these 3 things, then how do we conduct that experiment? Then the statistician will give you the plan. It's like you have stones with you, you have bricks with you, you have cement with you, right? Now, how to construct the house? As I said, you approach the architect, that he will give you the plan. First, you have to select certain things, that's up to you. Selection of treatments, selection of experimental material, that's you have to work on that. So you have to screen the research papers, you have to study the research papers and see what the research is right now going on in your field, and as per that you will select your research problem, your research objectives. And once your research objectives are framed, then you need to discuss that what are the observations, what are the variables you are going to study in your research, right? Yeah. So as I said, the stats part, you have to be aware of these statistical terminologies, like what do we mean, what we mean by replication, what we mean by randomization, what we mean by standard deviation. These things you can study at your own level, and if you have any problem, you can consult any person of that particular field. Like if it is statistics, you have to consult a I was studying this, I couldn't understand this properly. So at the end of the day, you have to, be in touch with the statisticians or whatever field it is, because as I said, research is a teamwork. It may involve you, the biotechnologist, it may involve you, the biochemistry, a person from biochemistry, a person from zoology, a person from statistics. So that's how the research is conducted. You need to take help from all. No doubt the major part will be yours. Let's suppose 70% will be yours as a nanotechnologist, but maybe the 20% comprises from the statistician, from the biochemist, from the zoologist. You have to consult all of them at different stages. Any other question? Anybody? Okay, best of luck for your research. Best of luck for your life. Okay, guys. Okay, Allah Hafiz. Have a great day.